In this lesson, we're going to go over how to write names and formulas of ternary compounds. So in the last lecture, we did binary, which meant two different elements bonded together. Now we're going to look at groups of three elements bonded together. These are going to include something called polyatomic ions. So that prefix poly means many, so they're going to be made up of many different atoms, and since these are going to be ions, they're going to have a charge. Polyatomic ions are a charged group of two or more bonded atoms that can be considered a single ion. So we know ionic compounds are made up of a cation and an anion. Your anion might be polyatomic, but we're going to consider that like a single anion. When we're looking at polyatomic ions, they cannot be split. You cannot break up the polyatomic ion. They're bonded together. You also cannot change the subscripts. The subscripts cannot be altered. So in your Honors Chemistry resource packet, you will find a page that says common polyatomic ions. So we can see that we have groups of atoms that are bonded together. Whatever those subscripts are, that's what they are. You can't change them. And we also see that they all have charges. All right, so let's start with formulas first. A lot of these rules or a lot of these steps are going to be the same as binary. So anytime we're writing an ionic formula, whether it's binary, ternary, the cation is always written first. The cation is written first. We still need to determine the ratio of ions needed to make a neutral compound. Since we're still dealing with ionic compounds, they're still going to be neutral. I need a net charge of 0. The only thing that is going to be different is if you need more than one polyatomic ion. If you figure out your ratio and you need more than one polyatomic ion, it must go in parentheses. All right. First one, we'll use sodium and sulfate. Next one, we'll do calcium and phosphate. C. Let's do aluminum and hydroxide. Last one, we'll do ammonium and chlorine. All right, I didn't write this step, but just like with binary, the first thing we want to do is figure out the charge of our ions. So we can look up sodium on the periodic table. Sodium is a group 1 metal. Sodium will have a charge of +1. A little tip for your polyatomic ions, they are arranged according to charge, but each column is in alphabetical order. So go through the first column, look for sulfate. If you don't see it, go to the second column. We're looking for sulfate. Be careful, because I have a sulfate, A-T-E. I also have sulfite, I-T-E. So you want to make sure you're picking the correct polyatomic ion. Sulfate is SO4, 2 minus. All right, the cation comes first, the anion goes second. We want to figure out what is the ratio needed to make a neutral compound. The only thing that you are looking at is the charge. Ignore the 4. That just means that I have 1 sulfur with 4 oxygens bonded to it. It does not affect the charge. The charge of the sulfate ion is -2. So if sulfate is -2, but sodium is only +1, I would need 2 sodiums for every 1 sulfate. Remember, keep the polyatomic ion together like a unit. The polyatomic ion is SO4. So then my formula for sodium and sulfate would be Na2SO4. Next one, calcium. Again, we can look up calcium on the periodic table, figure out its charge. Calcium is going to be +2. Phosphate, and again, be careful because there's also a phosphite. Phosphate is PO4, 3 minus. PO4, 3 minus. So calcium has a charge of +2. Phosphate is -3. These have to cancel out. The only way to get this to cancel out is to make it even. So I would need 2 phosphates. If I have 2 phosphates, each with a charge of -3, that gives me a -6. 2 phosphates, each with a charge of -3, gives me -6. That means calcium has to equal +6. Since calcium has a charge of +2, I would need 3 of them. So I need 3 calciums and 2 phosphates. 3 calciums and 2 phosphates. Here's where that last rule goes into play. If you need more than 1 polyatomic ion, it must go in parentheses. Right now, this looks like I have 42 oxygens. So what I want to do is put phosphate, PO4, in parentheses, and the 2 goes on the outside. Next one, aluminum has a charge of 3+. Hydroxide is -1. I can look up hydroxide again on my polyatomic ion reference sheet. Hydroxide is OH1-. I need to cancel out a +3. That means I would need 3 hydroxides. And again, anytime you need more than 1 polyatomic ion, it must go in parentheses. If I have 3 hydroxides, each with a -1 charge, that's like a -3. That's going to cancel out that +3. If you look at your polyatomic ion reference sheet, notice that almost every single ion on here is negatively charged. But if you look down at the bottom, there is one cation that we use, and that is going to be ammonium. Ammonium is NH4 1+. Ammonium, NH4 with a charge of +1. Chlorine is just regular old chlorine from the periodic table, -1. So again, we want to look at our charges and figure out the ratio needed to make a neutral compound. Well, ammonium is +1, chlorine is -1. +1 -1 is a net charge of 0. So my formula would be NH4Cl. Again, keep the polyatomic ion together like a unit. Sulfate is SO4, so we leave it as SO4. Phosphate is PO4. We leave the polyatomic ion together as PO4. Hydroxide is OH, so we write OH. Ammonium, NH4, so you're going to write NH4. Keep the entire polyatomic ion together like a unit. Up next, we did formulas, now we have to do naming. And again, a lot of these rules are going to be the same. Just like with binary, the cation is written first. Just like with binary, never change the name of the cation. Never change the name of the cation. These ones are going to be even easier than binary. Never change the name of the polyatomic ion. All right, name the following. All right, first one. Na is the cation. The cation comes first. Never change the name of the cation. Na is sodium. Next comes NO3. So I would want to find NO3 on my polyatomic ion reference sheet. NO3 is nitrate. Never change the name of the polyatomic ion. Don't add any letters. Don't change any letters. This would be sodium nitrate. My next one, NH4 is ammonium. Cation comes first, never change the name of the cation. It's also a polyatomic ion, never change the name of a polyatomic ion. OH is also polyatomic. OH is hydroxide. So this compound is ammonium hydroxide. Ca is calcium. The cation comes first. Never change the name of the cation. CO3 is polyatomic. It is made up of many atoms. 1 carbon and 3 oxygens. Find CO3 on your reference sheet. It is carbonate. This formula is calcium carbonate. Last one. Cation comes first. Never change the name of the cation. Mg is magnesium. A was NO3, which was nitrate with an A. This is NO2. So again, be careful about the polyatomic ion. Make sure you're finding the right one. NO2 is nitrite with an I. So this would be magnesium nitrite. Last thing to mention, you do need to be very careful with spelling because spelling does count. For example, NO3 is nitrate, while NO2 is nitrite. They only differ by one letter. If I had the nitrogen anion, we would drop the ending and add IDE. This would be nitride. So nitrite and nitride, again, only differ by one letter. So be very careful with your spelling and make sure you're paying attention to those endings and picking the correct polyatomic ion.